Mrs. H here. Today we're going to be looking at nature of matter. We have a few vocabulary words, and so our objective is to look at the three states of matter, describe the differences between those states of matter, and then give some examples. And also look at physical properties of matter. So, what is matter? We need to identify this. So, matter is anything that takes up space, and matter is all around you. Matter is made up of atoms. We'll look into atoms later in this trimester. Sorry. So, the chair you're sitting at, if you're fiddling with something in your hand like I am right now, so this folder, those are all things made up of matter. But don't forget, matter can be things that we can't see with our eye, like the particles in the air, or the teeny tiny viruses, or bacteria living on the surfaces. So it's not just about the things that we do see, but matter can be things that we can't see with our eyes. And the key to remember is matter is anything that takes up space and that is made of atoms. So matter, we can describe matter with its mass. So objects that we put on a balance, and we're going to measure the mass of the matter. That is a way we can describe matter, is by its mass. So when we say matter takes up space, we're also saying that matter has mass. So when we're talking about how much space they're taking up, we're talking about the volume. And those two are two different things. So mass is how much stuff, and then the volume is how much space that stuff takes up. So then we look at types of matter. So solids, liquids, gases. You should be familiar with this. This is not a new concept. And we call these states of matter. There is plasma. We're not really going to highlight on plasma, but plasma is in lightning, and it's the sun. And this is excited matter or ionized matter. So let's look at these three in a little more details. So when we're looking at a solid has a fixed composition. It has a fixed shape, and you don't need a container for it to take this shape. These are particles that are packed together. They can easily identify the volume because you can measure the volume of the object, with a meter stick or a yardstick or a ruler. They're not necessarily, just because it's a solid doesn't mean it has to be heavy or that it has to be dense. So an example of this, I could have gold or I could have a pillow. So they're both solid objects. They both have a definite shape, but clearly one is more dense because it has more stuff in that space. So a way we describe solid is it's having a fixed position. Another thing to note about the molecules in a solid is that they are moving, but they're moving in a vibration, and so they're not free to roam. They're really stuck in that one spot, but they are moving. They are vibrating back and forth. Where liquids take the shape of the container. These they do have a density, but again, depending on the type of liquid, is going to be dependent on the type of density. These are going to have a specific volume, but the volume is going to be the shape of the volume is going to be based on the shape of the container. So I can put a liquid in a bowl, I can put a liquid in a cup, I can put it in a pan, I can put it in a sheet pan, I can pour it on my desk, and it will have a specific volume, but the shape of that substance is going to be based on the shape of the container. Other thing to note about liquids, liquid molecules are moving. They are moving more rapidly than a solid. They're more than just vibrating back and forth, they're actually rolling over each other. And there is typically more space between our molecules, between the solid and the liquid. And then our last one is a gas. Gases expand. These are not really considered dense, although they do have a density, but because they can expand and go everywhere in a room, so if I left a gas out of a container and I let it into the room is now the container, and so it's going to spread out. You can compress, and that means like pushing it into a container. So think of like a canister of oxygen or a canister of helium. You can compress it into the container, but as soon as I let that valve open, it's going to spread out into the room. And again, there will have a volume, but the volume is a little more closely linked to pressure and the container. So it gets a little more complicated. So examples of solids, your book, mountains, the desk, the sea. So these are all solid objects. Now, all of these objects can be made of different things. They can be made of metals, they can be made of plastic, they could be made of glass. And based on the type of product they're made out of is going to determine how tightly packed those molecules are and how dense are those molecules. And again, these all are going to have a very fixed shape. When we think of a book, there's definitely a shape that you're thinking in your head. If I say a pencil, there's a definite shape that you're thinking in your head. Now, the pencil is a plastic, it's a hardened plastic, and we make it into the shape of a pencil. But if I took that pencil and I heated it up and I excited those molecules and it becomes a liquid, it will change its shape. So what kind of solids do you think of when you think of the word solid? So then liquids, examples of the liquid, we usually think of water, but oil's a liquid, milk's a liquid, your pop. Now pop does have gas in it, but and how do we know that? We open up the pop and you can hear the fizz. The fizz is the release of the gas. But when we say a pop goes flat, what's happened? The gas has escaped it, and so we're just left with the liquid. So again, when you're thinking of a liquid, what kind of things do you think of? Do you think of soap? And again, soap is pretty generic. Do you have liquid soap? Do you have solid soap? So again, you need to be thinking in context. Just being very vague with soap, it's going to be dependent on what kind of soap your family buys. And then the last one, gases. So our gases, the oxygen we breathe, the carbon dioxide we exhale, the helium to fill up balloons. So these are all, again, examples of gases. But remember, those are the ones we're familiar with, but nitrogen can be a gas. So that may be one that we're not as familiar with. So let's go ahead and think about these. Name 2 solids, liquids, and gases from the picture. Can you identify them within the picture? Okay, so now we talked about states of matter. Now, the state of matter is actually a physical property of matter. And when we're talking about physical properties of matter, this is just their physical appearance. What do they look like? How hard are they? What state of matter are they in? What color are they in? Can they conduct heat? How densely packed are the particles in the substance? So again, all of our physical properties are just describing its physical appearance or what these objects look like. So is it shiny? Is it dull? Is it soft? As opposed to a chemical reaction or its chemical properties. So how it reacts with other things would be considered its chemical properties. We're specifically going to just stick with physical properties for right now. So our physical properties that we look at, what color is it? Is it translucent? Is it opaque? What temperature is it a solid at? What temperature is it a liquid at? What temperature is it a gas at? Does it conduct electricity or heat? So how hot does this material get? In If I put it in a pan of boiling water, is that spoon, it's gonna get hot really quick, as opposed to wood, which wouldn't get hot because of its conductivity of heat or even electricity. So the volume, how much space does this object take up? We will look at density in our coming weeks. Density actually compares its mass per value. So how much stuff does it have packed into how much space? So again, going with temperature, one of the things that we're looking at is the boiling, freezing, and melting points, which I kind of talked about earlier. Mass is often associated with density, which is volume. So those three sometimes are linked. And then again, our states of matter. So these are all the physical properties describing matter. We can also look at how hard it is, how soft it is, its luster, how malleable is it? Can we bend it easily? Like this isn't very malleable, but this is kind of malleable. And malleable we usually think of as in terms of metal. So again, there are other physical properties that we can look at, but these are the most common physical properties. So then when we're thinking about our solids, liquids, and gases, we can actually use a diagram to describe these particles inside them and what they look like. We use what's called a particle model. And so if I would look at the picture of a solid, liquid, and gas and describe it on the inside, this is what these particles inside a solid, liquid, and gas would look like. The solid is a definite, uniform shape. It's going to take the shape of a very specific, definite shape. Our liquid, they're still kind of touching, but they're not as uniform, not as stacked. And then the gas, these gases are going to be very spread out. They're going to actually spread as far away from each other as they can. Now, the question is, why are these things doing this? Well, a solid has less energy. So their kinetic energy is lower. So those molecules have less energy to move. So they're vibrating because they still have energy, but a lower amount of energy. Where a liquid has more energy than the solid. And so these are going to be rolling and moving around. I kind of think of liquids as you remember as a kid when you would go to those fun parks and they had the balloons in the pool and you could jump, or not the balloons, the little balls, and you jump in them and the balls are all flying around and rolling around and what have you. They're not flying in the air, but they're flying around in that pool. So that would be how I visually think of a liquid. And why are they all rolling around and moving around that way? Well, because they have the kinetic energy. They have the energy to do that. And so then a gas has a lot of energy. It has a lot of kinetic energy. So they're flying around and moving around and all those things. So in terms of our solid, liquid, and gas, we're really talking about the kinetic energy of these things that require them to move. Now, here's the other thing. When we're talking about temperature is actually the measure of that kinetic energy. And different molecules respond differently to kinetic energy. So, for example, this water, room temperature, it's going to be a liquid. Now, this is still a measurement of its kinetic energy. So it has kinetic energy, but to be a liquid, it still has the same amount of kinetic energy as this object right here, because they're the same temperature. This liquid here and this solid here have the same amount of kinetic energy because they're the same temperature, right? But what happens? This one is a solid. This one is a liquid. So this needs less kinetic energy, right? To roll around and start moving like that than this does. Again, same temperature, same kinetic energy. So, if you have any questions, please feel free to ask for help and come to me. Bye, guys.